Welcome back to the Deep Dive. This is where we take all those raw ingredients, the sources, the research, your notes, and we distill them down into the most powerful, concise knowledge you can get. We're here to give you that shortcut, that path to being thoroughly and surprisingly well-informed. Okay, let's unpack this. Today, we are getting into a domain that, it really defines modern technology, DevOps and SRE, Site Reliability Engineering Management. And to be super clear, we are diving deep, but strictly into the essential level concepts. Our mission today is to figure out how these high-performing organizations manage to, impose structure on what is basically technological chaos. How do they innovate so fast without constantly breaking everything? We're charting that journey from, unpredictability to rock-solid stability, and we're calling this deep dive Order from Chaos. So if you're new to operations, maybe you're prepping for a new role or shifting your career, or you're just, intensely curious how companies like Google or Netflix keep the lights on, this is for you. We're going to be focusing on the philosophies, the human structures, the communication guardrails that make all the tech actually work.
And if we connect this to the bigger picture, what you really need to get is that the essential principles of DevOps, they're not really about a specific coding language or, a particular cloud provider. Fundamentally, they're about people, about sociology and process engineering. The concepts we're going to cover today, SRE philosophy, all the incident roles, error budgets, blameless postmortems, these are really the structural tools. They're what transform that reactive, constant firefighting into something proactive, a reliable service delivery mechanism. We're exploring how teams agree collaboratively on how to manage risk and failure.
It's just so fascinating to me that the foundation of a reliable system, it's not found in some perfect architecture diagram or, code that's possible to break. It's actually found in the willingness to acknowledge failure and to learn from it. So we're starting with something that seems totally counterintuitive. If you want reliability, you first have to learn how to fail safely and efficiently. And this commitment, this idea of learning from mistakes without pointing fingers, that is the absolute heart of the SRE culture, isn't it?
That's absolutely right. And that brings us straight to the postmortem. After any kind of outage, big or small, you have to create a formal document. But we always insist on that one word. It has to be blameless. The whole philosophy is that we have to see failure not as, one person's screw up, but as a system problem.
Okay, but blameless is so easy to say, and I imagine incredibly hard to do in the real world, especially when a big outage is costing the company millions and the CEO is, not looking. Why is it so critical to get rid of the blame?
It's purely pragmatic. It all comes down to data integrity. One of our sources really implies this. The second an engineer is afraid of being punished, a bad performance review, maybe losing their job, or just public shame, they immediately stop investigating, honestly. Yeah, their focus shifts to self-protection, to minimizing their own liability. And right there, you lose access to what actually happened, the real sequence of events, the human errors, the subtle little organizational problems that led to the incident in the first place. And this is where that aviation analogy you mentioned, it's just the perfect historical parallel.
Right.
Think about it. An airplane has an incident. The NTSB, the National Transportation Safety Board, they show up. Their entire goal is systemic improvement. They get the black box, they analyze every piece of debris, every radio communication, every maintenance log. Their mission is not to throw the pilot in jail or fire the mechanics on the spot.
No, of course not.
Their mission is to understand the exact confluence of events. Maybe it was mechanical failure, maybe poor training, maybe the manual was confusing, or just plain human error. They want to know what led to the failure.
So they're basically crowdsourcing safety knowledge from every failure.
Precisely. And the result is that planes are safer for everyone tomorrow. Because the regulations, the training, the aircraft designs, they all get updated based on the transparent, unvarnished truth of what went wrong. We apply that exact same lens to our software systems. The goal isn't punishment, it's systemic improvement.
Okay, so an outage happens. A manager's demanding answers. What actually needs to go into that official postmortem document? It can't just be a note that says, oops, our bad.
No, it has to be highly structured. The SRE best practices demand 4 specific things. First, the root causes. And that's plural. It's not just the final mistake, but the whole chain of events that allowed it to happen.
Okay.
Second, the resolution steps you took during the incident, all documented chronologically. Third, you list the concrete lessons learned. What did we learn about how our system behaves or where the gaps are in our organization? But the most important part, the thing that actually drives change, is the fourth one. a prioritized list of action items to prevent it from happening again.
So that's the roadmap.
That's the roadmap for turning failure into future reliability. This postmortem is the organization's promise, really, to spend time and resources fixing the system, not just the symptom.
And we said this document has to be shared widely. You don't just email it to the engineering manager, right? Why is that?
Well, if you only send it to one manager, the learning gets stuck in a silo. The source material is really clear on this. The document has to be distributed widely, usually on the engineering org's internal wiki or a shared drive. This makes sure that every other team that might have a similar vulnerability or every new engineer who joins the company can read it and learn from someone else's mistake. It standardizes the knowledge. It spreads the systemic improvements across the whole company.
So it sounds like this is the recommended first step after a major outage, before you even start dealing with all the external pressure.
It is. The sources confirm it. Developing that postmortem, distilling all that chaos into structured, shared knowledge is the recommended first step. It helps you structure the narrative, it makes sure the documentation happens while everyone's memory is still fresh, and it immediately shifts the culture towards learning, not blame.
Okay, so once we've built that culture of learning from failure, the next logical step is to prevent burnout, to preserve the health of the team by tackling all those chronic interruptions. We're kind of shifting from reacting and learning to proactively preventing exhaustion, both for the system and for the humans. Let's talk about being on call. It's one of the most stressful parts of an ops role. And what burns people out faster than anything, it's the noise. It's that constant stream of notifications, and you realize most of them don't even matter. You're woken up at 3 a.m. for a little network hiccup, or a microservice that crashed but then restarted itself in 30 seconds. It's self-healed. That alert demanded a human get involved, but no one was actually needed. It was unactionable.
That is the core problem that SRE is trying to solve. That alert noise creates operational fatigue, and fatigue very quickly turns into burnout. The SRE best practice is completely unambiguous here. You must eliminate unactionable alerts. If a system is designed to recover on its own, and the impact to the user is tiny or just momentary, the human operator should not be woken up. They shouldn't be interrupted.
So what's the new rule? What defines an alert that is worth waking someone up for?
It has to be like a sacred contract. An alert should only fire if it represents a current ongoing failure that requires a human to get involved right now, either to mitigate the impact on users or to prevent a bigger cascading failure. We have to raise the bar for what we call an emergency.
And cleaning up that noise is key, because a team that's just constantly chasing false alarms, they're eventually going to miss the real disaster when it finally hits: cognitive fatigue. So that's the reactive part, cleaning up the mess. But can we push this idea of reliability even earlier in the process? Shift left, as they say. Can we stop these issues from being designed into the system in the first place?
Absolutely. And this is where you see true SRE collaboration. It's not about waiting for a problem to happen. It's about preventing it from ever being born. When a new product or feature is being developed, the SRE team shouldn't wait for a prototype to be deployed or for the dev team to finish their first build. The best practice is to review the product design with the development team and give that operational feedback super early, right in the design phase.
Can you give me an example? What would an SRE look for in that design review that maybe a developer would miss?
Sure. A developer's probably focused on feature functionality, right? Does this new checkout button correctly process the payment? An SRE, on the other hand, is focused on resilience and capacity. They're going to ask questions like, what happens if our payment provider is down? What's the failover strategy? Have we designed this new database query to handle peak load, or is it going to lock the main user table on Black Friday? They're looking for single points of failure, for scaling bottlenecks, for bad timeout settings, and by giving that feedback early, before a single line of infrastructure code is even written, you engineer reliability into the very foundation of the product. That prevents catastrophic failures and all those unnecessary alerts down the line. It's just so much cheaper and easier to fix a design flaw on a whiteboard than it is to fix an architectural flaw in production when everything is on fire.
Right. So no matter how well we plan, or how many alerts we get rid of, or how carefully we review designs, failure is just inevitable. Things will break. And when that chaos hits, the system is down, the phone's ringing off the hook, customers are angry, organization is everything. You need a structure to prevent panic and paralysis. And this is where that analogy of a first responder team like a fire department or an EMT crew is so important. Think about an accident scene. You need a clear hierarchy. right? You need specialized tasks and unified communication. If 3 different people are yelling orders or everyone is trying to do the same thing at once, the situation just gets worse.
Mm-hmm.
That structure maps directly onto the SRE incident roles.
It really does. When a major incident is declared, and that means a failure with significant customer-facing impact, that organizational structure has to just snap into place instantly. The source material confirms that the incident commander, the IC, is the person who takes charge, and they must immediately assign at least 2 other key roles to make sure the response is structured and effective.
So who are these core players, and what are their specific jobs? We need to be really clear about their decision-making boundaries.
The 3 essential roles are the incident commander, or IC, the operations lead, or AOL, and the communications lead, the CL.
Okay.
The incident commander, the IC, they are the strategic brain. They are the only person who declares the incident. They define the overall recovery goals.
Like restore service fully or stop the data leak, that sort of thing.
Exactly. And crucially, the IC does not type commands. They direct traffic. They manage who's doing what, and they make sure the team is focused on the highest priority thing to fix the problem. They're focused on the what and the who, not the how.
So the IC is asking the question, do we need to roll back the database or just restart the front-end servers? But they aren't the one actually doing it.
Precisely. The person typing the commands, that's the operations lead, the OL. The OL is the tactical hands. They are the ones translating the IC's high-level strategy into actual technical steps. The OL is running the playbooks, gathering the data, deploying the fixes, coordinating the rollback. Their focus is purely on technical mitigation.
And what about the outside world, all that pressure from managers and stakeholders?
That is the exclusive domain of the communications lead, the CL. The CL is the buffer. They're the internal and the external voice. Their job is to manage all the updates for all the stakeholders, internal managers, product owners, and if it's really bad, external customers. And by having this dedicated role, the CL protects the IC and the AOL from being distracted. If the CEO calls demanding an update, the IC just says, talk to the CL. It lets the technical team actually focus on the fix.
Okay, so the IC sets up the team, but before anyone even touches a server or sends an email, what is the absolute first thing the IC has to do according to SRE protocol?
This is so foundational. Before any mitigation even starts, the IC must establish a communication channel, a place where all the incident responders and leads can talk to each other.
The war room.
The war room, exactly. Could be a video call, a dedicated chat channel. Why? Because chaos is the enemy of coordination. If people are using different email threads and chats and phone calls, you have no single source of truth. Establishing that one dedicated channel instantly organizes the whole response effort. It makes sure everyone is working from the same information.
Which again just highlights that point. Structure and communication come before you even try to fix the technology.
Every single time. You can't fix the tech if the human system is failing.
So the team is formed, they're talking to each other, but the clock is ticking. This brings us to a huge philosophical decision point during an incident. Do we spend an hour trying to find the precise root cause of the error? Or do we prioritize speed to just minimize the impact on the customer? SRE principles always favor stopping the bleeding first.
Always. Mitigation first.
So let's run a quick scenario. We just pushed a new feature, maybe a canary release, to just 5% of our users. And 5 minutes later, our monitoring system just starts screaming. We see a huge spike in 500 errors. Database latency is through the roof. The system is obviously unhealthy, and that new release is the most likely suspect.
In that exact scenario, an alert spike right after a recent release, the absolute non-negotiable first step you must take is to roll back the recent release. If you're supporting a customer-facing app where errors and latency are spiking, rolling back to the last known good configuration is the fastest and safest thing you can do.
I can almost hear a curious developer pushing back on that.
Yeah.
Saying, but wait, if we roll back, we lose our new feature, and we still don't know what caused the problem. Maybe if we just spend 15 minutes investigating, we can find a simple config tweak and fix it without losing the feature. Why do we have to ignore that temptation?
Because in SRE, during an incident, the customer experience is king. The whole philosophy is mitigation over investigation. Rolling back is low risk and it's high speed. It immediately stabilizes the service. It reduces the blast radius of the error. If you spend 15 minutes investigating and the issue turns out to be really complex, well, you've just guaranteed an extra 15 minutes of downtime for your customers.
Right.
By rolling back, you stop the customer pain. You get the service back to that previous stable state. Then, once the fire is out, you take the broken code offline into a test environment, and you can spend hours or even days tracing the root cause at your leisure. This protects the team from all that pressure, and it ensures that a system failure doesn't turn into a customer relations disaster.
Okay, so while the AL is frantically working on that rollback, or maybe just after, the communications lead's job becomes, the most politically critical role in the room. They're managing the internal and external perception of this whole crisis.
The CL is the organizational diplomat. They shield the technical team from that constant flood of status requests that would otherwise just derail the whole response. Imagine you have a major outage. The tech team is trying to focus, but 50 different stakeholders, product managers, sales directors, the PR team are all firing off urgent emails demanding when will it be fixed.
A nightmare.
A total nightmare. So the CL has to be proactive. And the source insight is really specific here. Even if the situation is so chaotic that there is no estimated time for resolution, no ETR, the CL still has to do two crucial things. They have to provide periodic updates to all stakeholders, and this is the most important part. They must commit to a next update time in every single communication.
Wait, hold on. If they don't know the ETR, how can they commit to a next update time? That sounds like you're promising something you can't actually deliver.
But that's the genius of it. You're committing to a communication cadence, not a fix. You might say something like, we're currently investigating the issue. We've mitigated about 50% of the customer impact by rolling back a release. We have no ETR yet, but the next update will be provided at 14.3 UTC.
I see.
That simple commitment that they will hear from you in 30 minutes no matter what, it manages expectations. It relieves all that pressure. Stakeholders who know an update is coming don't feel that urgent need to harass the engineering team. It creates this psychological window of calm for the IC and the RL to just focus on their jobs. It turns anxiety into patient waiting.
So we've now got the culture, this blameless learning, and we've got the organizational structure of the first responders. But how do we maintain this balance day to day? How do we set up the guardrails that tell the company when it's okay to move fast and when it has to slam on the brakes and prioritize stability?
This requires formalized management structures, specifically service-level objectives, SLOs, and dedicated environments. And this is really the core philosophical tension in modern tech companies. You've got the product development team, and their whole job is velocity. Push new features, iterate quickly. Then you have the SRE or operations team, and their job is stability. Avoid outages, keep things reliable.
And those two goals are just fundamentally in conflict because every change you make introduces risk. So we need something to resolve that conflict without it just turning into shouting matches.
And that's what
the error budget comes in, right? Framed like a financial budget.
Exactly. The error budget is the shared objective truth that forces everyone to collaborate. It all starts with the service level objective, the SLO. And SLO is just a target, usually a percentage of successful requests or uptime. Like, our service must maintain 99.9% availability this quarter. Now, if your target is 99.9% availability, that implies that 0.1% of unavailability or errors is acceptable. That 0.1% of acceptable failure. That is your error budget. That is the money you are allowed to spend on risky deployments, on minor incidents, on service slowdowns before there are consequences.
So a higher SLO, like 99.99%, means a much smaller budget, and it's harder to innovate quickly. This must mean the product team and the SRE team have to really negotiate that initial SLO. What does that conversation look like?
Oh, it can be very difficult. A product manager might want to promise 4 nines, 99.99% to major enterprise clients.
Okay.
But the SRE team knows that going from 3 nines, which is about 8 hours of downtime a year, to 4 nines, which is only about 52 minutes of downtime a year, requires a huge exponential investment in infrastructure, redundancy, and process.
And that investment comes at the cost of new features.
Right.
Which is why the sources stress that the foundation of this whole system is the policy itself. Before you ever have a major incident, the organization has to develop an appropriate error budget policy in cooperation with all the service stakeholders. Development, product, SRE. Everyone has to sign off on the SLO and, more importantly, on the consequences of spending that budget.
Okay, let's talk about that consequence, because that's where the budget really gets its teeth. What happens when the service runs out of money? When it misses its SLO?
The policy dictates that the development team must shift its focus immediately. They stop all work on new features, a feature freeze, and their new priority is improving service reliability. If you spend all your money on failure, you stop spending on risky innovation. Instead, you invest in stability. You pay down technical debt, improve your monitoring, build automated fixes.
That is so profound because it's a self-correcting system. It automatically prioritizes stability exactly when it's needed most. It takes the subjective, stressful human debate about freezing a release pipeline completely out of the equation. It makes the decision objective, data-driven. The error budget acts as the ultimate guardrail, ensuring that reliability isn't just an aspiration, it's an enforceable constraint on how fast the business can move. If product pushes too hard and breaks the system, they get penalized by losing the ability to ship features until the budget is replenished. It forces them to become reliability advocates themselves.
So the next tool for imposing order is environment separation.
Yeah.
And the goal here is super simple. You never, ever test risky changes on paying customers. Let's use our restaurant kitchen analogy again. You can't have the experimental chef trying out some wild new recipe and the junior staff getting trained and the maintenance crew adjusting the gas on the fryer, all in the main kitchen while people are eating dinner.
Right.
If the new recipe is a disaster or the fryer fails, paying customers are immediately affected. You need separate spaces for different kinds of work.
That analogy perfectly illustrates the problem of environment contamination. It's a massive source of outages. The source material warns about this, that you get consistent bugs and outages when companies let developers use the production environment for coding, testing, config changes, or especially load testing. When those lines get blurry, stability just vanishes.
So what's the solution?
The essential strategy is just clear, dedicated separation. You have to have at least 2 key layers before you get to production. 1, a development environment. This is strictly for writing code, debugging, unit testing. This is where the messy, broken initial code lives. And 2, a separate test environment, sometimes called staging or pre-production. This environment needs to mimic production as closely as possible, and it's used for integrating code changes, running configurations, and doing critical experiments.
Why is that separation so important for load testing specifically?
Oh, load testing has to happen in the test environment, never in production. Load testing means you are intentionally trying to break the system by simulating a massive spike in user traffic. You're trying to find the application's breaking point so you know how to scale it.
If you do that in production.
You're basically launching a denial of service attack on your own users. You're causing real performance problems or even crashes. The sources highlight that load testing is a crucial part of capacity planning. Before a big, predictable event like the holiday shopping season or a huge product launch, you have to stress test the application. This tells you where the bottlenecks are. Is it the database, the network, the app logic? Finding that breaking point in tests lets you proactively scale the production environment so it doesn't get overwhelmed when the real traffic hits.
Okay, so order isn't just about technical stability, it's also about financial efficiency. We've worked hard to make things reliable, but we also have to run our core systems in a way that's, fiscally responsible.
Yeah, and when you get to that level of operational stability we've been talking about, you have reliable SLOs, clear capacity planning, you often end up with these very predictable business-critical workloads. They use a fixed set of resources, like servers or databases, for months or even years at a time.
Right.
And when you have that stability and predictability, you can make much smarter financial decisions. The source insight confirms that for a stable, critical workload running on a fixed set of resources for a long time, the recommended way to lower your cloud bill without hurting performance is to purchase committed use discounts, or CUDs.
Okay, what are CUDs in simple terms?
CUDs are basically a long-term contract with your cloud provider, usually for 1 or 3 years. You commit to spending a certain amount of money or using a certain amount of capacity, and in exchange, they give you a significantly reduced hourly rate.
So it's like buying in bulk.
It's exactly like buying in bulk ahead of time. The provider gives you the discount because you're giving them guaranteed revenue and predictability.
So when would CUDs be a bad idea?
They're great for stability, but they're terrible for volatility. If your workload is ephemeral, meaning it scales way up and down all the time, or if you're planning to migrate the whole system to a different region in 6 months, then committing to a long-term discount would just be, well, a financial mistake. CUDs are a reward for having operational confidence and predictability. You should only use them on the foundation of stable, well-established workloads. It's another way that SRE discipline, that focus on stability, pays off this time on the balance sheet.
Okay, we built the human system for order. Now we have to apply that same order to the physical infrastructure itself. We're moving beyond just manually clicking around in a console. We're defining our servers, our networks, our configurations in code. This practice, infrastructure as code or IAC, brings all that engineering, discipline, consistency, versioning, repeatability to managing systems. So if the environment strategy gave us separate kitchens, IAC gives us the standardized, reproducible blueprints for those kitchens.
That blueprint analogy is excellent. Think about infrastructure as code using a tool like Terraform as a way to save the precise game state of your entire system. If something breaks, you can instantly roll back to a previous known good state, or you can perfectly reproduce the entire system in a different region.
But that only works if it's managed properly.
Exactly. It only delivers that value if you manage it with the same rigor you manage your application code. As teams grow, you have multiple DevOps engineers all potentially working on the same cloud resources, updating firewall rules, creating networks, resizing machines. If they aren't coordinating, they will absolutely overwrite or corrupt each other's work. It's inevitable.
So how do you enforce that coordination and integrity?
The essential requirement is version control. You must store the Terraform code in a version control system like Git. This gives you a complete history of every change. It's auditable, and it lets you collaborate using established workflows. But just storing the code isn't enough. That storage has to be paired with clear procedures. This includes mandatory code reviews by peers. So another engineer has to approve your infrastructure change, and unit testing before those changes get merged into the main repository. This prevents what's called configuration drift, and it makes sure that the repository is always the single peer-reviewed master version of your infrastructure. For large, stable teams, this is non-negotiable.
And what's the practical danger if they don't do this?
The danger is that configuration drift. So engineer A updates a firewall rule manually in the cloud console, then engineer B runs the IAC code from the repository, which has no idea about engineer A's manual change. And it promptly reverts the firewall rule, maybe exposing the system or causing an outage. IAC systems enforce what's defined in the code, but they rely on that code repository being the ultimate source of truth, and that truth has to be enforced through rigorous peer review.
This brings us to the really tricky part of IAC state management. When we use a tool like Terraform, it doesn't just run the code. It also has to know what the current state of the infrastructure is in the real world, so it can figure out what needs to change. And that information is stored in a critical state file.
The terraform.tf state file is the ultimate map between your code and the actual resources deployed in the cloud. If that map gets corrupted or lost, or if multiple processes try to access it at the same time, you get chaos. Here's the classic failure scenario. You're running your IAC through a CI/CD pipeline. One morning, you notice that every time the pipeline runs, it's not updating your existing stuff. It's deploying entirely new copies of the infrastructure. New servers, new networks, new databases.
That sounds like a catastrophic money-wasting nightmare. Why on earth would it do that?
It's a state management failure. The pipeline isn't correctly tracking the state. It thinks, my job is to manage infrastructure stack X. I don't see any record of stack X currently running, so I guess I need to build it from scratch.
And you end up with all this orphaned, expensive, useless infrastructure.
Oh, right. And the fix is technical, but it's essential. You have to confirm that the pipeline is storing and retrieving the terraform.tf state file from external cloud storage using the right Terraform backend, like the GC's backend for Google Cloud.
So why external storage? Why not just keep the state file on the machine that's running the pipeline?
Because local storage just fails in a collaborative, distributed world. External storage, like a dedicated cloud storage bucket, makes sure that all runs of the CI/CD pipeline, whether they're triggered by engineer A in London or engineer B in New York, are referring to the exact same single source of truth. And what's more, these cloud storage backends usually provide features like state locking. This means if one pipeline run is currently modifying the infrastructure, the state file gets locked. That prevents a second run from starting at the same time and causing corruption or deployment conflicts. This external, locked state file is the foundational requirement for safe, collaborative, and consistent IAC management. And it ensures you optimize your cloud spend by not creating all that orphaned infrastructure. So we've completed our deep dive into the essentials of managing order from chaos. And this journey really confirmed that modern operational excellence is built on these layers of structure. We started with the foundation of culture, right? Understanding that reliability starts with blameless learning from shared postmortems. Then we moved to that essential organizational structure, defining the clear first responder roles, ICCLOL, that you need to manage an incident efficiently. After that, we set up the objective guardrails, the error budget, which turns reliability into an enforceable financial constraint on speed, and the environment strategy that separates risky experiments from stable services. And finally, we looked at the blueprint, confirming that codifying your infrastructure with IAC and managing that state file correctly is how you maintain consistency and safety over time.
The core takeaway here is just undeniable, isn't it? This essential level of DevOps and SRE knowledge. It really confirms that operational excellence is fundamentally about communication, about clearly defined processes, and about culture, the human-centric disciplined system. That's the primary factor that drives stability. The technology is just the tool set. So what does this all mean for you? If you are taking on a new operations role, or you're just trying to influence better stability in your company, focus on these human systems first. Understand the communication protocols the CL uses. Know that hierarchy of response during a major incident. These social and procedural things, they are your most powerful levers for success. And here's a final provocative thought for you to consider. You now understand that every time a development team decides to freeze feature releases because of instability, they aren't just being arbitrary or overly cautious. They've simply run out of money in their corporate error budget, a budget they agreed to upfront. So if you were a product manager and you had a real-time dashboard showing that error budget ticking down day by day, how would the shared, visible status of that budget fundamentally change the conversations and the relationship between your development and operations teams on your next project? Think about how objectivity transforms conflict. We'll catch you on the next deep dive.